I'm going to do one more example for those who feel like they need to see the process again. If you feel like you've got this, go ahead and fast forward to the end of the video and grab the You Try problems. So step 1, substitute our ordered pairs into y equals ax squared plus bx plus c. So my first ordered pair, I've got 3 as my y value. 2 squared gives me 4. My second function, or ordered pair, 3 is my y value. 6 squared. And finally, negative 3 is my y value, 8 squared. Again, I want to use those c values to cancel first, just because they all have that coefficient of 1. So I'm going to use my first 2, multiplying my first one through by a negative, and adding them together, I get 0 equals 32a plus 4b, and then my c's cancel. So I'm going to go ahead and use my first and third, since I already made those negative. This time I have negative 6 equals 60a plus 6b, and my c's cancel. Alright, I'm going to use my b's to cancel again. This time, my least common multiple of 4 and 6 is 12. So I'm going to go ahead and multiply this by a negative 3, and this one by a 2. So we have 0 equals negative 96a minus 12b. And the second one, I have negative 12 equals 120a plus 12b. Adding them together, I get 24a, and my b's cancel. Dividing both sides by 24, be careful on this one. I get a lot of students that will say negative 2, but we are dividing by 24, and negative 12 24ths is negative 1/2, not negative 2. So my a value is negative 1/2, and now we just back substitute to solve for b and c. So I'm going to use my purple equation to solve for b because it's got smaller numbers again. So we get 0 equals half of 32 is 16. Subtracting 16 from both sides and dividing by 4, I get a b value of negative 4. And again, using my very first blue equation to solve for c, sorry, that was a positive 3 to begin with, equals 4 times a plus 2 times b plus c. And just doing a little bit of algebra here, adding 10 to both sides, we get a c value of 13. Sorry, I forgot to keep showing you the steps. And finally, we write our equation with our a, b, and c values. So we have y equals a x squared plus bx plus c. And that is our quadratic equation for this function. And your U tries. Apparently, I am missing the data table for number 1, so just go ahead and do the U try number 2 for this day.